Alright, thanks for hanging in there. We're almost to the end. So the last thing we're going to look at are solving some equations that are in what we call quadratic form. So they may not have an x squared term, they may just be quadratic in form. And an example of what that would look like is if we have x to the fourth, we've learned that that's x squared to the second. So we can actually say that this equation is quadratic in x squared. So that lets me use some of the methods that we've already learned to solve quadratics to solve something that looks a little more difficult. Now you notice this says solve each equation using U substitution. I'm very aware that there are other ways to do this, and if you go out on an app or on the internet, it may show you a different method. So notice the instructions call for using the U substitution, so that's what I'm going to be looking for. Okay? If I have this problem where my highest term is to the fourth, and then I have a quadratic and then a constant, more often than not, we're going to let U equal to P squared. The reason that that works is because then if I square U, that means we would also square this side. So U squared is P to the fourth. So when I come over to my problem where I see P to the fourth, I can substitute U squared minus 3 P squared is U minus 4 equals 0. Now luckily enough, this problem is actually factorable. You can use quadratic formula if you want to. I'm going to factor because it's a little simpler and quicker. We know we would need U and U to get U squared. The factors of 4 that can give me 3 are going to be 4 and 1. And since the 3 needs to be negative, we need negative 4 and positive 1. So then this works zero factor property just like it did before. So we're going to set each one of those factors equal to 0. So I get U equals 4 or U equals negative 1. Now what's important to remember here is we have not finished solving the problem, right? The original problem is in variable P, and right now we are in U. So now we have to back substitute. So if you go back to our key, it says U equals P squared. So where this says U equals 4, I'm going to say P squared equals 4 because that's what U is equal to. Same for this one, where there's a U, I'm going to say P squared equals negative 1. Now both of these problems are quadratics, and I have a squared term equal to a constant. So at this point, we can use the square root property to solve. So remember, we just take the square root of each side. So we know the square root of a squared undoes itself. We pick up that plus or minus, don't forget. And the square root of 4 is 2. We'll do the same thing for this one. So this one's going to undo. Now we got a negative under there. So remember, for this one, by definition, the square root of negative 1 is I. So we actually have 4 solutions. We have -2 and 2, and we have -I and I. You can write the solutions like this or like this. Either way is fine. The second one to me is a little less intuitive, but we're not going to give you like 5 different kinds of these. These are basically the 2 kinds that we're going to deal with. So when you see that you have the square root of the variable in the middle, we're going to let u equal to the square root of x. And like we did last time, if I squared u, then we would be squaring x squared. And of course that squared and the root will undo itself and leave me with x. So now over in my equation where I have x, I'm going to write u squared. Where I have the square root of x, I'm going to write u minus 6 equals 0. It turns out this one is also factorable. So we'd get u times u. To get 6, that will add to -1. We're going to need 3 and 2. And we'll need -3 and +2. So then we use the 0 factor property. And then of course we have to do the back substitution. This is u equals square root of x. So where I have u, I'm going to write square root of x equals 3 in both places. So this is kind of the opposite of the last one, right? We had p squared and wanted p, so we took the square root. Now we have the square root of x, and we want x, so we're going to need to square both sides. So the square and the square root will undo and leave me with x. Sorry, that's a 3. So 3 squared is 9. And then the square root of x squared leaves me with x. And -2 squared is 4. So my 2 solutions are 4 and 9. Alright, we got one more. And this one is going to look very familiar. It's something, again, that we've worked before. But now it's not going to be factorable for us to solve. But this is one of those work rate problems like we did before. And it's actually kind of worded the same way. We have an experienced word processor and a beginning word processor. And of course we have together. So we're still going to say 1 over the experienced plus 1 over the beginner equals 1 over together. And this says together, they can create a document in 6 hours. So that's the T. Alone, the experienced word processor can process the document 2 hours faster than the beginning word processor can. So we're going to need some expressions for these. So the experienced word processor can process it 2 hours faster. So that means our variable is going to be the beginning. That's, we don't know, but we can determine the experienced if we know the beginning. Now you also have to be careful here because it says 2 hours faster, and that might lead you to think faster is +2, because if a person is running 2 miles per hour and another is running 2 faster, they're running 4. But because we're dealing with time, if they process it faster, then that means it's actually less time. So the experience is going to be x minus 2. Okay? So let's fill in what we know. Our experienced is x minus 2. Our beginner is x. And together is 6. So I'm sure this brings back fond memories. We need an LCD 6x, x minus 2. And remember, I do have to see where we multiply every term in the equation by the LCD. And then you can show me what cancels. So I'm going to be left with 6x. 6 times x minus 2. And then x times x minus 2. So we get 6x plus 6x minus 12 equals x squared minus 2x. Alright, so let's clean it up. This is 12x minus 12, x squared minus 2x. And of course, because I have a quadratic term, I need to be equal to 0. So I'm going to subtract the 12x and add the 12 so that we'll be equal to 0. Now, you can try in your head really fast if you want. The factors of 12 are 12 and 1, 6 and 2, 3 and 4. None of those are capable of giving me a 14. So that means we're going to need quadratic formula. A is 1, B is negative 14, and C is 12. So we get x equals negative times B plus or minus B squared minus 4 times A times C all over 2A. So this is positive 14 plus or minus. I think because these numbers got so big, I just went ahead and multiplied and added this whole thing. So I did negative 14 squared minus 4 times 1 times 12 all at one time. And I got 148. Hopefully that's correct. Over 2. Then you see my directions stay around to the nearest tenth. So I'm going to split this into the two cases. One's a plus, one's a minus. And then you can just use your calculator again. So we're going to approximate. And I think I got 13.1 for this one. And looks like I got 0.9. Now both of these are actually positive, but if you're talking about 6 hours together, you can probably guess that it's not going to be the 0.9, but that it's going to be 13.1. And X was the beginner. So it would take the beginner 13.1 and it would take the experienced 13.1 minus 2, which is 11.1.